said fast forward the video to a certain time so that you wouldn't waste time.
Sorry.
And I said just to do those 2 slides. And that would be the 2 slides where you're practicing. It's going to crash. That would be the 2 slides where you're practicing finding the trig function of any angle based on the information they give you. You need to know that while it feels like we've maybe already covered like a lot of stuff, we've really only covered one basic concept, and that's the trig function of any angle. It's just that each section has changed how the angle is given to you. Like in the very first section, it was just the special right triangles. And you can get the trig function of those. In the second section, it was any triangle, and you were still using your basic trig, and then you had your six trig functions, so you found the 3 others. And then in this one is when it's any angle positive or negative. You're using the concept of coterminal angles. You've got complement and supplement. You've got the 6 trig functions now presented in terms of x, y, and r.
Somebody come back in the flags.
Come back here?
No, go back out there. Flags.
Oh, okay. You're looking at.
Oh, he got sued.
You're looking at the triangles based on x, y, and r. Remember, the takeaway is x is always the side that runs along the x-axis, so you can't mess that up. X is on the x-axis, and y is, think of the bow tie. Y is the height of the bow tie, whether it's up or down, and then r is the radius, which is always positive every time, every day, all day. R is positive. Then we talked about oh wait, the board just died. Okay. Hold on. Then we talked about finding the trig function values based on how the picture is presented. Right here, the pictures were presented to you. You just had to label x, y, and then find r using the Pythagorean theorem. This is the same concept in all 3 problems. It's just it gets more challenging because of the radical. It's the same thing though. Then here, it was the same exact thing. Instead of giving you the picture to start with, they gave you the point. So you labeled where the point would be, and then you drew your right triangle, and you labeled your x, your y, found your r, and you found your 6 trig functions. Right? And then this was one of the 2 slides I asked you to do on Friday. This was the second slide. So let's just go one at a time. Did y'all do example 4?
Yes.
Did anyone have any questions on example 4? Does anyone need me to work it? Example 4. 4 was they give you one trig function value and they tell you what quadrant you're in. So you draw it and label it, and then you find your 6 trig values. Tan is opposite over adjacent. You need to remember opposite. Imagine like this motion with your arms. Opposite is the height of the bow tie. Well, height implies which one? X or Y? Y. The height of the bow tie is Y. So this is Y over, so you can see it. This is Y over adjacent. Adjacent, theta is always at the origin, and adjacent is always on the x-axis. So this is x. So your y is 2, your x is 3. How do you know which one's negative? Right? If we're in quadrant 2, so draw C. So quadrant 1, 2, which means x is negative, y is positive. So that tells me right here that x is negative 3, y is positive 2. And then I would draw my picture in quadrant 2. Bow tie, remember? Bow tie. There's theta. Oh, there's theta. X is negative 3, y is positive 2. What do I have to find? Hypotenuse. Pythagorean theorem, you should have come to root 13. And then you would find your 6 trig functions. So does anybody need me to finish working now? You can find sine, cosine, tan, and then secant, cosecant, cotan. E9, extra example 9. Same exact thing. The difference is they're giving you sine, and you're in what quadrant? You're in the third quadrant. You've got to draw a picture. You've got to know when they give you one trig ratio, they're giving you 2 of the 3 numbers you have to have. When we say 3 numbers, we mean the 3 sides of the triangle. It depends on the trig function to know which one they're giving you. They're giving you sine. Sine is opposite over hypotenuse. Here's what you've got to have memorized. Sine is opposite over hypotenuse. Actually, I think, let me look. So I'll go ahead and give you this. It's the formula sheet, so you can get an idea of what it looks like.
We write on this one.
Yeah, and I'll just make a new one for exam day. Yeah.
I was just going to write on it and use it for the.
Oh, no, you can't do that.
In the video, you just didn't give the answers for 9 and 10.
All right, I'll do that. If I remember correctly, I think that group was like, I got it, which was no big deal. They got tired of it. And that's one of the things that makes these lessons long is the textbook only gives the one example, and I usually come in and give additional examples to make sure if anyone has questions. So if you look at the formula sheet I just gave you, notice over there on the right with the circle, it's all generic. There's no numbers involved at all. It's just to remind you that the x is on the x-axis, the y is the height, and then the radius, of course, is the hypotenuse. You've got the Pythagorean theorem on there. When I say that sine is negative 1/3, that's opposite over hypotenuse. The hypotenuse is what in the formula? R. And then opposite, so look at the picture in the formula. Go to theta. Now go opposite. Opposite is what letter? Y. So this is y over r. So that's how you use that formula sheet. So they're telling you the y is -1 and r is 3, and we're in quadrant 3. So you got to think of how you draw C. 1, 2, 3. So draw your bow tie. Don't do this. Don't. That's not part of a bow tie. seniors, y'all have a meeting today in Flex. You will go to the theater during first Flex after you check in for attendance to your Flex teacher. No clue what it's about.
It's registration.
So now I'm going to fill in my picture. Theta always goes right here in the corner. The y coordinate's -1. The radius is 3. You would have to find x using the Pythagorean theorem. You do get the square root of 8, but you need to reduce the square root of 8 into square root 4, square root 2. The square root of 4 is 2. And because it's left, it would be negative. Let me show you. I remember grading these in years past. Like I know where people mess up. They label the wrong quadrant. They use the wrong formula. They draw their triangle wrong. They forget the negative. Like they forget to put the negative in there. Those are all, there's multiple places that you can make a tiny mistake and then it messes the whole thing up. If you forget a negative, I will give partial credit as long as you show your work. Because then I can justify it. All right, so your answers here. Sign they give you. Cosine -2 root 2 over 3. Tan root 2 over 4. Cosecant -3. Hold on. I don't know. Oh, because, so tan would be, so from theta, opposite over adjacent. First of all, the negative over negative is going to go away. And then also we have a root 2 on the bottom. So we're going to multiply by root 2 over root 2. Show our work. I'm just going to come down because I'm running out of room. So across the top I would have root 2. On the bottom I would have 2 times root 4. If you need to see right there, that would be root 4. What does root 4 become? Just a 2. So I'm going to take that off and write 2. And now you can see how it ends up being root 2 over 4. When you rationalized this 2? Oh, okay, yeah, only multiply by what the problem is. And the issue is the root 2. Now, on the test, if you were to have on your paper, you know, like this, and then you messed this up, then I would give you partial credit, okay? So just make sure on the test that you're showing your steps along the way, so that if there is a mistake, I can find where the mistake is and honor partial credit. Now, in my math lab, of course, they don't do that, but so that's why I don't like the raw grades until I've gone in and done partial. Cosecant -3, secant -3 root 2 over 4. Do you need to work that one? Yeah. Okay. I don't know. I just work here. Can I erase tan? We good? Brody, you staying with me or are you watching film?
I'm saying we.
Okay. All right, we're finding which one? Secant. Secant's the reciprocal of which one? Cosine. So I'm going to write cosine, which is -2 root 2 over 3. And then I'm going to write secant. All Alright, so that's 3 over 2 root 2, and I can't stand a negative in the bottom, so I'm just going to put it at the top. Alright, so there's my answer, but I've got to get it in the correct form. So I'm going to multiply by just the issue, which is that root 2. Multiply straight across. Trying to be out of everyone's way, but I'm also right. Alright, straight across, and I get this, right? But square root 4 is 2. So I'm going to change that to 2. And now you can see square root 2 over 4. Negative 3 square root 2 over 4. Is that what I said? Yeah. Cotan, did you get 2 root 2? Cotan? Does anyone need me to work E10? Mine's blank on here, but I can work it up there. Let's make sure your picture's right for E10. So they do give us one of the reciprocal functions, secant. Some people can work straight from that. I personally, I don't like it. I like to calibrate it back to sine, cosine, tan. So if secant of beta is 5 over 3, S, so opposite letter, then cosine of beta would be 3 over 5, and now I feel like I can actually draw my picture. Cosine is adjacent over hypotenuse. If you go to your picture, get your x, y, r by thinking to yourself, okay, adjacent to theta is x, and the hypotenuse is r. So they've just given you the x is 3, the r is 5, and we are in quadrant 4. So draw C. 1, 2, 3, 4. Do your little bow tie, triangle. X is 3, R is 5. Pythagorean theorem, you should have found Y to be 4, but you're in quadrant 4, so it's negative 4. Watch your signs. Watch your signs. I'm going to guess you don't need 6 trig function values because there's no radicals. You would just be shoving them into fractions, right? All right, go to the next slide. It's what we've been doing, but this time it's the quadrantal angles. So it's a little awkward, but it actually should be easier. If you come over here to this slide, it says find the sine, cosine, and tangent values for 90, 180, 270, and 360. What makes these challenging is you want to go in and draw a triangle, but you can't because it's a quadrantal angle. So at first you're probably like, okay, I don't really know how to do this because I don't see the triangle. But you need to fall back on the fact that when it's a quadrantal angle, first of all, you're dealing with the numbers 0, 1, and negative 1. So no radicals. Second of all, because you cannot draw the triangle, it's as simple as sine is y, cosine is x, and tan is y over x. And that's it. Okay, so let's take some notes. Notice right here, it says the definitions of trig functions still apply, but in some cases you have to be careful because the denominator, Lord is testing my patience with this board. It's like, let's see how long until you snap. but I'm not gonna do it. I'll just walk right out. I don't know. I don't understand why it doesn't. There we go. It's on. All right, let's finish. It doesn't make sense. All right. So what I was trying to underline is that sometimes when you're doing the sine, cosine, tan of a quadrantal angle, you end up with 0 in the denominator, which means you cannot actually evaluate it. It does not exist. All right. So let's look at this. Sine refers to the y coordinate. We talked about that. We said sine opposite, so like opposite, right? The height. Cosine refers to the x coordinate. And then tan refers to y over x. You might want to highlight what you just wrote down, or circle it, or make a note out to the side. Memorize this. Sine is y, cosine is x, tan is y over x when you're doing the quadrantal angles. Or one way to remember it is sining. Sining is just funny. It sounds like hiding. My boys are in the phase of anytime you talk about food, they laugh, or someone passes. I know. So I'm just thinking of signing, hiding. They would be giggling right now. When does that face go away?
Never.
Getting the girl dog. Brad's gonna come home one day and there's just gonna be a little cute dog with a pink bow on it, and I'm gonna be like, look at our new daughter. I'm surrounded by boys. Alright, look at the first one right here. We're gonna do sine, cosine, tan of this picture, this one, this one, this one, so you can see all. Sine of 90, our angle is 90. Sine of 90 means the y value. See, imagine the picture's not there. If I said, what's the sine of 90? You should think, okay, an angle is opening up to 90. Wait a minute, that's landing on an axis. Then you should think to yourself, so what is the coordinate point if it landed right there? It would be 0, 1, right? 0, 1. So this is the point. This is important. That's where you get your answer from. Sine means write the y coordinate of that point. The y coordinate is 1. Cosine means write the what? X coordinate. So it would be 0. Tangent means write the fraction y over x. So tangent 90 would be y over x, which is what? Undefined. It's a problem. All right, let's do another one. So the way this lays out is, what if I said to you, tell me the sine of 180? You would say to yourself, 180, where does that fall? That opens up and that lands on an axis. This is a quadrantal angle. We can't draw a triangle here. So we need the point. What are the coordinate points if I was to open an angle up and land on 180? It would be -1, 0. That's where your answers come from here. So this is your coordinate point, -1, 0. That's what you would have to know, okay? So sine is the y coordinate, cosine is the x coordinate, tan is y over x. And in this case, you get 0 for tan. All right, if we had 270, think to yourself 270. So it starts on the initial side, it opens up, you got 90, 180, 270. So it's going to land down here on the y-axis, which means we cannot draw the triangle. So you would think, what are the coordinate points of an angle down there? It would be 0, -1. So sine is the y-coordinate, x is the, or cosine is the x-coordinate, tangent is y over x, which is undefined. Just remember, if 0 is underneath, it's undefined. It's a no-go. Name a coterminal angle to 360 degrees. Zero. Coterminal means you subtract off a rotation or you add a rotation. You could have also said 720. All right, so same thing here. If I said, tell me the sine, cosine, tangent of 360, you should think to yourself, where does that fall? You got 90, 180, 270, 360. It lands back on the x-axis. Can't draw a triangle, which means you need the point. That would be right 1 and then stay. So that would be 1, 0. So sine is 0, cosine is 1, tan is 0 over 1, which is 0. Those are so simple, people miss them because they forget that you have to focus on the point. Then they forget sine is y, cosine is x, tan is y over x. Coterminal angles have the same. Luke, Tammy just said you did not show up.
I know, I'm coming back to flex. That's why we talked to Coach Sheldon. He said come back to flex, take a picture of both of us.
Who told you that?
Coach Sheldon.
He's sitting in here and said Shell told him to come back during flex to get a picture so that they could both be in it. But you have that meeting.
He's a senior.
Oh, okay.
We don't have to be in the picture.
Yeah, no, it's just a shot.
Oh, because he's the AD.
Oh.
All right. Coterminal angles have the same function values. So if I had said, what's the sine, cosine, tan of 0, you would have said these exact same answers. Okay. Come down here. Find the sine of, now don't find all 6. Just tell me the sine of -90. These are extra problems. Tell me the cosecant of 540. Tell me the sine of -90 and the cosecant of 540. For A, you should get -1. And for B, you should get undefined. Try them first. If you don't get it, I mean, I'm going to work it anyways, but try it first. So sine -90. Guys, there's a lot of different ways to do this. So if I go one route and you're like, I went a totally different route, but I got the right answer, then call me over and let me look at the route you went, okay? We don't have time to cover every possible way to look at it. And the problem with it, and the reason for that is because coterminal angles have the same function values. So we could see, like, you can actually answer this question using negative 90. You can answer this question using 270. Where'd I get 270? I added 360. So that's why there's so many different ways to answer the question. Sometimes I just draw, like if it's an angle I know where it is, whether it's positive or negative, then I'll run with it. Sometimes if it's ugly, I like to calibrate it. You're going to hear me say that a lot. I calibrate it back to a number between 0 to 360, and then I run with it. So here, I know where negative 90 is. I know negative 90, like this is positive 90, right? Watching my rotation, negative would go this way. So I know that this is referring. It makes me think it's the outlet. It can't be the board. I don't know. Ah! That's the software, the Active Inspire. They not? Oh. They hit the door.
Open the door and yell at them anyways.
Huh?
Open the door and yell at them anyways.
I don't want to, no.
Do it.
I don't want to yell. All right. Negative 90, I know where that is. That is opening the angle up, like, and landing right here. So I can't draw a triangle, which tells me I need the point. What would the coordinates of this be? 0, negative 1, right? That would be the coordinates of that point. So now sine tells me to pull which one? Negative 1, the y coordinate. If you had done 270, then you would have still landed here. You'd still have 0, negative 1. You'd still have negative 1 as your answer. All right, cosecant 540. There's two things here that I don't like. I don't like the reciprocal function, and I don't like being beyond 360. So I'm going to take 540 and calibrate that by finding the coterminal angle 180, right? So I'm going to say I'm actually finding the cosecant of 100. Okay, it is the board. It's the board. So I need to turn in a ticket. Oh, maybe I'll get a new board in 2 years. They're like, no, it still works. You'll be fine.
When I come look at it.
Oh yeah, when they come look at it, it's not gonna have any problems. I'll show them this video. All right, so I'm gonna find the cosecant of 180. So all I've done is taken the original problem and I've written it with the coterminal angle that is between 0 to 360. And now I'm gonna tell myself, now wait a minute, I don't like cosecant because that's a reciprocal function. You could run with it if you wanted to. But the cosecant of 180 would be the same thing as 1 over the sine of 180, right? I know where 180 is. 180 opens up and lands on the x-axis. So you got to think of like your coordinate points. It's opening up, it's landing here. That would be left 1 and then 0. So what's the y coordinate there? 0. Now watch, that 1 just carries over. This becomes 0, and that is undefined. If this seems like a lot, don't forget you could just type it in your calculator. And it's going to give you, I know, while lot. We get bogged down in like drawing the picture and the X, the Y, the R. But these are just basic trig functions that you could type in. Now you can't type cosecant. You'd have to type 1 over sine 180, and then you would get an error, and that would tell you it's undefined. If you go back and type sine negative 90, I believe your graphing calculator should be able to tell you negative 1. It shouldn't give you an error on that. So don't forget that safety net of you can type it in. Okay? All right, you want me to set a timer, a 2-minute brain break? Okay. Yes. No. Wait. Hold on. I was trying to pause the video. Yeah. I gotta be quick. Uncle, I think she's done.
Uh-oh.
Wait. Go to this slide right here. This should look familiar, right? You found these trig functions in 6.1, I think it was. And then we noticed the chart. So like the sine of 45 would be opposite over hypotenuse rationalized. So root 2 over 2. The cosine of 45 is also root 2 over 2 because it's an isosceles triangle. The tan of 45 is 1 because 1 divided by 1 is 1. And then sine, cosine, tan of this triangle is either 1/2, root 3 over 2, or root 3, if I remember correctly. Those all filled in a chart. This chart right here is the chart that you learned in section 6.1. That chart is on your formula sheet for the exam, okay? So you don't have to memorize it because we've already produced it, so there's no reason for you to memorize it. The only thing I don't like about the chart is the fractions are not written in stacked form, but I'll let it go. Here's a new vocab word, and it comes up a lot this whole semester. It is the phrase reference angle. Reference angle is, now this picture looks really complicated over here. Let me break it down for you. I hope you're looking. Notice that my yellow angle right here starts on the initial side, and then it opens up and lands in quadrant 2. And notice that if you can tell, we change, you can see this arrow to say it's opening up right here and it measures 150 degrees. You see that? Okay. The reference angle, stay with me, is the acute, what's that mean? Not ugly, right? It's the acute angle, meaning less than 90. You with me? Reference angles are always less than 90. It's the acute angle that is between the terminal side collapsing to the x-axis. Look right here. The reference angle of 150 is 30. Because what's the gap from where 150 lands to the nearest x-axis? 30 degrees. You with me? So the reference angle is 30. The takeaway, I need a blue. The takeaway right here is that this little angle, 30 degrees, is my reference angle for 150. Let's take some notes right here. The reference angle is always acute. Not ugly, but acute one. I'm sorry. And then you need to think of it as closing the gap to the nearest x-axis, or quadrantal angle, but it's always the x-axis. It's always going to be what collapses to the x-axis, okay? Never the y-axis. Think of why would you do that? Like don't go to the y-axis, it's to the x-axis, okay? So, this question right here kind of just dives right in. It says, find the sine, cosine, and tangent for the following angles. And then I noticed that I typed here to use the reference angle. You could do just 225. You could go to your calculator and you could type sine 225, cosine 225, tan 225. But it's going to give you the decimal values. Up here in this chart, only 3 answers in that chart have pretty decimals. The 1/2, the 1, and 1/2 again. All of these that have radicals have ugly decimals, which means you can't use your calculator to just type it in and get the answer. You have to actually know what you're doing, all right? Okay, how do you know what you're doing? Ready? I'll lay it out for you. First of all, 225 is the angle we're working with. I'm going to sketch, kind of come over here, and I'm just going to sketch a blank quadrant, or grid, coordinate plane. Sketchy? Is that what you said? Oh. You've got to know where 225 lands. Use the quadrantal angles to calibrate like where you are. So this is 0. I hope you're watching me. This is 0. This is 90. This is 180. This is, I went too far, right? You're right, 270, but I went too far. Sorry, I didn't mean to make it sound like you were wrong. The goal was 225. So I said to myself in my head, I'm like, okay, 0, 90, 180, 270, woo, back up. So it's in quadrant 3, which tells me the angle's opening up and it's landing right here. So I'm going to draw a line to say this is 225. But I'm not going to use 225. I'm going to use the reference angle. So what is the reference angle from 225? You're going to the nearest x-axis. So think back to what was the value of that x-axis. This was 180. It's just a matter of subtracting to get the reference angle. You get 45. So watch where I put 45. 45 is going to go right here where we're usually write theta. The reference angle is 45. Now I can finish my right triangle. This should start to look familiar. I'm going to finish my right triangle to the nearest x-axis. And I have a 45, 45, 90. You've got to memorize these side links. Go back to this. You've got to have these memorized. 45, 45, 90 is not bad at all. You got 1, 1, root 2. Right? I'll show you how to do this one in a second. You got 1, 1, root 2. What's the hypotenuse in the 45, 45, 90?
Root 2.
The root 2. So I'm going to come here and say, okay, so that's root 2. And the legs are what? 1 and 1, but I'm in quadrant 3. So adjust it. This is 1 and 1, but I'm in quadrant 3. So this is -1, -1. And now you find, you're not doing all 6, you're just doing the 3 original. Now you find sine, cosine, tan of that. See the complexity? Like it's the same. We're still just finding sine, cosine, tan. Right?
If you're doing sine of 225, I mean, even though the numbers are still sine 5.
What she has? Are we doing?
225 or 45, which is fine.
You're you're doing 45. You're doing the reference angle. We're calibrating a number. So what's the purpose of it? The purpose is you're going to take these ugly angles, 225, and you're calibrating it to a reference angle that will always be, you with me, 45, 30, 60, or 90. Because those are the angles of the special right triangles that we learned. So, your reference angles, this is a safety net, hope you're listening. Your reference angles should always be 45, 30, 60, or 90 if it was a quadrantal angle. Okay? We're finding sine, cosine, tan of 45. Notice, this is where your chart comes into play. Sine of 45 is root 2 over 2. So the chart's giving you the answer. There's just something you need to remember. The chart shows no negatives. So you just have to remember what quadrant you're in. So sine would be opposite. I don't really use the chart immediately. I use the chart if I need to rationalize. Sine would be -1 over root 2, so I know it's negative. Then I go up here and I read, oh, it's root 2 over 2. So you would write sine 45 equals negative root 2 over 2. Cosine would also be negative root 2 over 2, because it was isosceles. Tangent should be positive 1. All right, let me draw the big picture for you again. Yeah. Y'all know what the definition of crazy is? When you do the same thing over and over and you expect a different outcome. All right, I think the board officially died. If I had given you this picture right away, and I said find sine, cosine, tangent, you would have just ran with it, right? This goes back to like 6-1. You with me? The complexity here is I'm saying find sine, cosine, tan of 225. You have to draw it. You have to find the reference angle. You have to remember what quadrant you're in, so what's your negatives, and then you answer sine, cosine, tan. All right, everybody try B. Try finding negative 780. All right, what do you know about negative 780? Yeah, negative 780 is like super, super, super beyond 0 to 360. So how do I get it back?
Subtract 360.
Subtract?
Add.
Add. So if I add 360, I get negative 420.
Do it again.
Do it again. I get negative 60.
Do it again.
Do it again. I get 300. Now I know where I am, right? Okay, you got to think of where 300 falls. So you got 90, 180, 270, 360. So it's in quadrant 4. So this is going to be quadrant 4. So draw your picture. You got it rotates, it lands here. So there is 300. The reference angle is the gap that closes it to the closest x-axis. Well, if I was to continue rotating, this would be 360. So what's the gap? 60. And now I can finish my right triangle. I have 30, 60, 90. Which brings us to memorizing the units of memorizing the units of measurement for 30, 60, 90. Let me get my mouse, because at least the computer works, and I'll just use the mouse to click between slides. All right. So coming back over here. What? Great question. Tell me what your thought process is. Okay. Correct. And what angle did I draw? You're on the right track.
If you go the other way, you get 30 instead of 60.
What do you mean the other way?
Like if you were to go clockwise.
With what angle? Which angle are you drawing? Are you drawing 300?
I just did that it rotates twice at 720, and then one more time.
Oh, it's 780. Did you write 720?
No, I'm saying that 2 rotations would be 720.
Oh, okay, okay.
Yeah.
360, 360.
Yeah, and then if you were going clockwise, you go to 810 instead of 30.
Where's your 810?
It's like that one.
Go to the nearest x-axis every time. The reason why is because the reference angle has to be part of the bow tie, okay? So always collapse to the x-axis. If you go to the y-axis, you would get 30, but the reference angle needs to be needs to form a triangle that's in that bow tie picture. If I was to draw negative 780, I would have rotated in the other direction. Yeah.
Like I said,
It does not matter because they're coterminal. That's the beauty of it. Okay, so look at these formulas. Look at these formulas. When we start this test, what I'm going to do is have you go on your paper and draw these triangles, like fill these in. You're going to draw 2 triangles. You're going to draw a 45, 45, 90, and a 30, 60, 90, and you're going to fill in the sides. Then I'm going to walk around and just be like, yes, you got it, or okay, you need to fix that. You with me? And then that way you don't take the whole test with the wrong formulas, because that wouldn't serve any good purpose. You shouldn't have a problem memorizing the 45, 45, 90. It's 1, 1, root 2. Can't mess that up. This one's the one that's a little challenging. First of all, just know the numbers you're working with. You got 1, 2, root 3. 1, 2, root 3, okay? Remember that the hypotenuse has to be the longest. If you forget that 2 is the longer number in there, then type root 3 in your calculator and you're going to see it's not bigger than 2. So that lets you know, okay, 2 is the hypotenuse. Also remember the short leg is 1, okay? Start from the short leg and then label your other legs, like the other leg is root 3, and the hypotenuse is 2. So coming over here, this picture, I got to finish it. Find the hypotenuse. The hypotenuse is 2. I'm at my marker. There we go. Hypotenuse is 2. Find the short leg. The short leg is 1. The short leg would be opposite of what angle every time? Opposite of the shorter angle, the smaller angle. If this is 60, then this is the short angle, the small angle. So this over here is 1. This is the short leg. Short leg. Always start with it. And then that lets me know this is root 3, but it's in quadrant 4, so it's negative. Then you would find the sine, cosine, tan of 60 there. Find the sine, cosine, tan of 60. So remember sine, cosine, tan, those answers are in the chart. You just have to remember to watch your negatives. So for sine, did you get root 3 over 2? Root 3 over 2 for sine? Negative, sorry. Negative root 3 over 2. Yeah. Cosine, positive 1/2. And tan, negative root 3. I don't think you have any problems writing the sine, cosine, tan. So we don't necessarily have to finish the next 3 extra examples that I made up. But I do want to practice drawing the picture and getting the correct reference angle. So go to the next 3. Do me a favor, just do the beginning steps where you're drawing out like where that angle lands, and then you're identifying the reference angle and drawing and labeling the triangle. Do just that part. So like this right here, like what we just did here. Do that for the next 3 examples. To make sure you're doing it right. Electrocuted. Oh, I can use my writing tablet. I just got so many safety nets. So you're drawing the picture, and then you're finding the reference angle, then you're filling in the triangle. Just sit over here because the USB doesn't reach. Why is that thing flashing? It's like straight now. This is really very well. Like, right. Yes. So negative 330. I don't like dealing with negatives. You could work with it. It's no big deal. It just means remember to start on the initial side and rotate clockwise because it's negative. So this would be negative 90, 180, 270, 330, right? So it would land out here. This would be negative 330. If you don't like working with negatives, then just come over here and add a rotation, and you would end up with the exact reference angle anyways. So the reference angle is 30 degrees. It's going to go right here to the x-axis. I'm going to finish my triangle, and then I'm going to memorize that I'm working with the numbers 1, 2, root 3. Or if you want to do them in order, you could do 1, root 3, 2. I know the hypotenuse is 2. The short side is 1. This is 30, so opposite of it would be the short. That leaves this as root 3. Not drawn to scale clearly at all. And then you would finish sine, cosine, tan. Oh, they want all 6. You don't have to, you don't have to do that. You can practice it if you want. I've got the correct answers on my paper. But mainly I wanted to make sure you could draw the picture, get the reference angle, and label the sides.
Are you going to be doing the upgrade?
Yeah. Has everyone tried E12 yet? Have you had a chance to try it? So 600 is a little too much for me. I would subtract off a rotation. What's 600 minus 360? 240. Okay, I know where 240 is, so I'm going to sketch the quadrants. I'm going to try and sketch it bigger so you can see it better. The strobing is giving me a headache. All right, 240. So that's 90, 180. If I go all the way to the next one, it's 270, so it lands in here, right? So draw that out. This is 240. Collapse it to the closest x-axis. So I've got to backtrack. The closest was 180. What's the gap between 240 and 180? 60. So that's my reference angle.
Teachers and students, please pardon the interruption. Students, just for a moment, I want to talk to you about lunches. As always, we talk about respect, honesty, and service. Part of that is how we carry ourselves and our actions during lunchtime in the cafeteria.
Never
Of course, here we want you to be able to lunch on time. We want you to be able to go to the media center, the gym, in different places like that, so you have an opportunity to eat and talk with your friends. That's always what we want. However, first lunch especially, you need to make sure that you, when you get your food, you need to make sure that you take a seat. That's number one. Second of all, first lunch, you need to make sure that you are cleaning up after yourself.
That would be the freshman.
And also,
Right.
you need to make sure that you're using your trays, your belongings, whatever that you need to put in the trash, you need to make sure that it gets there before the end of lunch. Also, if you're eating in the Tiger's Den or you're eating by the auxiliary gym,
What's 495 minus 360? 135?
let's make sure that all lunchers are doing that, and especially first lunch, you need to make sure that you take care of that. As always, students, you do what I ask you to do, and I don't expect anything different today. Thank you, and have a great day.
Also, this is a reminder about the mandatory flex meeting today. The juniors will come to the theater during first class.
What is
I didn't know.
with their teachers for an
30,
Stop
35,
behavior during the third flex.
50. Oh, it's 45, right? Yeah.
So junior, third flex,